Okay, so we should be on page 25 of our interactive notebook to do some practice examples. And I want you guys to take a look at your at-home practice or your homework practice packet at number 24. At number 24. It says, for universal gravitation, reducing the distance by a factor of 3 has what effect on the force? Now, I'm going to let you guys in on a little secret. When I was your age, these questions used to always bug the daylights out of me, and I used to always just guess because I thought, well, how am I supposed to know how things are reduced by or doubled by or anything like that? And one day I'm sitting taking my physics exam, and I was in college, and I used to always say to myself, well, I'll just get these problems wrong because they're just too hard. They're just too difficult to deal with. And the test that I was sitting in, as it turns out, everything else was way harder than thinking about what happens when you double or triple or reduce something. And I realized that if I was going to get any points on this physics test, that I needed to figure this out. And so I came up with a trick that I'm going to teach you guys today. So we're going to start with something that you already know or that you're already aware of. So in your notes, I want you to draw a triangle. I'm sorry, this is sliding all over the desk, so I'm having a really tough time here. And I want you to draw a bigger triangle next to it. Okay? And if I were to say that the length or the base of this triangle was 4, and the base of this triangle was 8, and the height of this triangle was 10, and then I were to ask you what the height is of this triangle was, I'm hoping that you would come to the quick and fast conclusion that the solution to that would be 20, because this increases by a factor of 2, right? So this goes up by a factor of 2 each time, so that gives us a value of 20, yes? So far so good? So we're going to take and apply kind of the same idea, but we're going to use an equation that we're really comfortable with right now. The equation that we're going to use that we're really comfortable with is the F equals ma equation, because we've been using it for the last 2 weeks basically. So we're going to say, we're going to do this example problem. If we say, if you double the mass of an object, what happens, to the force? So that's our question. If you double the mass of an object, what happens to the force? And these are the questions that I used to always blow off in my physics tests. I'd be like, I'm just going to get this wrong. And the reality is, this is probably one of the easier questions to answer. And here's why it's so easy to answer. We know the equation for force is F is equal to mass times acceleration, right? So here's what we do in this case. Step 1 is you're going to assign values for the initial equation. Okay, so we're going to assign values for the initial equation. So in other words, I'm going to say, and you guys pick an easy number. That's the best advice I can give you, is to pick an easy number. So I'm going to say, for example, we're going to make the net force in this case equal to 100. And I'm just picking numbers at random. So now we have to have two numbers, when you multiply them together, have to equal 100. So let's pick any two numbers. Well, in my case, I automatically see that 25 times 4 is equal to 100, right? So is everybody with me so far? So we have a force of 100, we have a mass of 25, we have an acceleration of 4 meters per second squared. So now, what it's saying is, if you double the mass, what happens to the force? So once we assign these values for the initial equation, the next thing we're going to do is manipulate the equation according to the directions. So what are the directions telling us to do? They're telling us to double the mass. So now we have a mass of 25. So if we double the mass, it's now 50. We keep everything else the same. So now what's 50 times 4? 50 times 4 is 200. So what happens to the force? What is the relationship between 100 and 200? It goes up by a factor of 2. It doubles. Okay? So in this case, the answer would be the force doubles. See how easy that is? So you can use these kind of fake numbers, and you got to be real careful with this because sometimes people think that they can all of a sudden start assigning fake numbers to whatever they want. You can only assign fake numbers when you're working questions like this. If you double the mass, what happens to the force? Or if you cut the mass in half, what happens to the acceleration if the force stays the same? You'll be able to look and see what you can manipulate and what you can't manipulate. So we're going to do a practice problem real fast. You got to have your calculators handy. And I'm going to let you guys know right now that in any question that I ask you, it's going to be factors of 3 or 9. So when we pick our numbers out, it's going to be helpful to us to pick numbers that are even multiples of 3 or 9 because it just makes life a lot easier. That's not always the case. I'm just letting you know for this particular upcoming test, and with working with a universal gravitational constant, it has a tendency to be easier when you work in factors of 3s, and that's just something that we know, so we're trying to help you on it. And so that's why I'm passing that information on to you. So let's take a look at number 24. Number 24 says, and you guys probably can't read this because it's blurry, but it says, for universal gravitation, reducing the distance by a factor of 3 has what effect on the force? Okay, so now we know our original equation. So our original equation is force is equal to the big G times m1, m2 over d squared. Okay. Now, the universal gravitational constant is a really, really messy number. So for these problems, it's very easy to just ignore it. Okay, that's not always going to be the case for you, but for these problems and for just getting familiar with working these types of problems of if you double this, then what happens, we can get rid of this. Okay, it's always going to be helpful for you to ask first if you can get rid of it when you're manipulating these numbers. But what it's asking is it's reducing the distance by a factor of 3. So we're going to assign our values. And remember I said things are working in 3s and 9s for all of these questions that we're doing. So I'm going to pick a number that's divisible by 3 here because it'll be easy to reduce by 3, and 3 here, and 3 here. So I'm going to just say, for example, that our force is going to be equal to, let's say our mass 1 is 15, because 3 times 5 is 15. And our second mass is going to be 21, because 7 times 3 is 21. And our distance is going to be 24, because 24, and it's actually going to be 24 squared, don't forget that, because that's also divisible by. So now let's just calculate real fast what the force is generated if we just were to pick these random numbers. So on our calculators, we have to do 15 times 21. And we're going to divide that by 24 squared. Don't forget that squared, people. And we get 0.546. Okay, so in this case, force is equal to 0.546. So that becomes our first solution. Now, the second step, manipulate according to the directions. So the directions say reducing the distance by a factor of 3. So we got to take this 24 here and reduce it by a factor of 3. So we're basically going to be dividing by 3. Everything else is going to stay the same. So we have force is equal to 15 times 21. And we're going to reduce this 24 here by a factor of 3. So now we have 8 squared. Does everybody see how that works? Because we're reducing by a factor of 3. So we're basically dividing by 3. 24 divided by 3 gives us 8, and we're going to square it. So now let's calculate this value. So we have 15 times 21. And we're going to divide it by 8 squared, which is 64. Now we have 4.92. So the force goes from, let me write this down, 4.92. The force goes from 0.54 up to 4.92. It goes from 0.54 up to 4.92. So in this case, what I'm going to do here is I'm going to see, because this one goes from smaller to bigger, basically 0.54 times some number is going to give us 4.92. So in this case, 0.54 times x is going to be equal to 4.92. Now I'm going to divide both sides by 0.54 to see what that factor is. So we have 4.92-ish divided by 0.54, and on our calculators we get 9.11. Now looking at our answer choices, so basically this increases, so when we multiply this number here by 9.11, we get this. So what's it increasing by? It's increasing by about 9 times. So if you look over on your answer choice, now it says increases by a factor of 9. Okay, so let's take a look at one more example. Let's do number 25 in our notes. So 25 says, for universal gravitation, tripling one of the masses and increasing the distance by a factor of 3 has what effect on the force? So let's stick with our same problem. So we have m1, m2 divided by d squared. And we're going to leave our same, let's just leave our same values because it'll be a lot easier that way. So m1 is going to be 15, m2 is going to be 21, and our d squared is going to be 24. So we have 24 squared. So when we get that answer, we know it's going to be 0.54 because we've already done it. Okay? And you guys, these factors of 3 don't always work. They don't always, sometimes it's not 3 that you're going to pick. I mean, if you notice when we did F equals MA, we picked factors of 100 because 100 was a lot easier to work with. Pick what works for you. I'm just telling you guys right now that when you see these on the exam, they're all going to be factors of 3s and 9s. So you just want to pick 3s and 9s. Do you have to pick these numbers? No, you can pick whatever number you want. But I will caution you, stay away from 1s and stay away from 0s because sometimes they will cancel things out and do weird stuff and you can't really see a good relationship. So let's take a look at the problem. The problem says tripling one of the masses. So we're going to take this and we're going to triple it. So now we have, instead of 15, we now have 45. And we have to increase the distance by a factor of 3. So we're going to multiply 24 times 3. So we're going to get 72 squared. So we have originally, here's our original value. Now let's take a look. 45 times 21. And we're going to divide that by 72 squared. We get 0.18. So now we go from 0.54 down to 0.18. So what's this relationship between 0.54 and 0.18? Well, it's going to be decreasing. So we know that we can hit decrease. We can cross off anything in our answer choices that have anything to do with increasing. So we're going to, our answer is going to be decrease. What's the difference between this one and this one? Well, basically 0.18 times some number is going to give us 0.54. So 0.18 times some number is going to give us 0.54. And what you guys are going to find is that when you divide by 0.18, you're going to get 3. So the relationship here is we're going from 0.54, reducing by a factor of 3 to get 0.18. So our answer here is going to be C, decreases by a factor of 3. Okay? There's going to be some review problems for you to work on because your homework questions are in your notes. Your review page you're about to get handed out, that is due. You should be able to get it done by the end of the class today. And then your other assignment, once you're finished with that, in preparation for the test, is to go back to page 14 in your interactive notebook and get these big unit concepts done. Okay, you got to fill this whole thing out. That is your homework for tonight. So it says practice problems 22 to 25. We already did 22 to 25. So in your notes, so all you have to do is cross that off. It does say to complete the unit concept sheet. That's this guy right here. And you're also going to be doing your review sheet. Your review sheet will get secured to page 24 in your interactive notebook. It's a forces review. It's kind of a mixed bag of everything we've done so far so that you can get ready to go for the test. So your assignment, finish your forces review page that you're about to get handed out. That's going to go onto page 24. Turn back to page 14, fill out your unit concept sheet, and that's your homework for this weekend, for today before the test, okay? Thanks so much, guys.